Hey guys, what's up? What's up? Gotta welcome for some moles practice as promised. Okay, and we'll get right into it. Now, some things I want to tell you guys is that there might be a bit of delay because there's a 15 to 20-second delay every time you talk when I get it, or like, no, the other way around. When I say something, YouTube broadcasts it with a delay of 15-20 seconds. So whatever you say, um, I'm gonna, because you're getting the video late, I'll get it. I'll get your comments late as well. And my reply is also going to be late because it gets delayed. Otherwise, yeah, ठीक है. Good. Okay, let's start. Let's get good. ठीक है. So we're doing some moles practice this time around. If you guys want to do other practice for other chapters as well, I can also do that tonight or tomorrow. I'll have some time. Okay, let's begin. Starting with question number 3 in our worksheet. I believe it's shared. If it's not shared, I can put it there. And they're trying to say sodium nitrate is a white crystalline solid. When heated, it melts. How's the audio quality, by the way? Just quick check. It's always bad the first time. I'm famous. What are you talking about? Saad. What do you mean? I just see Saad, so. Oh, I'm famous because 108? That's not good. It melts and following reaction occurs. So this is sodium nitrate. And did it say it melts? Okay, it's melting and decomposing, right? So whatever it's saying, it's kind of irrelevant. You gotta focus on this equation. So let's do that. That's our equation. And this is the sample, 3.4 grams of sample of sodium nitrate is heated. So this is heated. That's too thick. This is 3.4 grams. You know, I find it funny when they go 3.40, like, like I know why it's important, but if they don't tell you why it's important, it's kind of useless to be there. Like in A levels, it makes sense, but in O levels, yeah, oh well. Sodium nitrate is heated. Calculate the number of moles of sodium nitrate used, and that's easy as pie. Easy as pie. 21st March, Sunday, time was 2:03 p.m. and I said easy as pie. Let history bear witness. The mass is, so let's write the equation down first. Those of you who are a little rusty. 3.4 grams, and the MR for sodium nitrate. Now, if I'm not too wrong, sodium is still 23 on the periodic table. I have no idea what nitrogen is. Is nitrogen 14? Okay, nitrogen is 14, and you have 3 oxygens of mass 16 each. And I put that in the calculator, which I can't see because it's so dark. That's great. That's just great. 23 plus 14 plus 3 times 16. And I'm getting 85, and 3.4 divided by 85 is 1 over 25, which is 0.04. I'm getting 0.04 moles. What's up? Hi Ramshaw, how are you? How many people? 6 people watching? That's not bad. Someone says something? There are only 2 people? I see there are 6 people. Saad, I don't remember you. It just says Saad. You could be any Saad I know. Are you Saad Mahmood? Number of moles of oxygen formed. Okay. Now this is where we have to do our ratios. Now this, if you haven't picked up on it yet, this question is divided into multiple steps, right? It's the same question we do. Normally I give you an equation and I tell you the mass of one thing, and ask you to find out everything, but they're dividing it into steps so they can grade it easier and they feel it makes the question easier. I strongly disagree, but this is what, how things are. So I gotta compare my sodium nitrate with oxygen, and let's do that. I have sodium nitrate, and they don't even give you enough space to work with oxygen, and the ratio is 2:1. So if this is 0.04 moles, the great gods of ratio tell me this is going to be 0.02 moles of oxygen. So that's easier said than done. 0.02 moles. Volume of oxygen formed, that's really easy as well. My volume is equal to the moles of something of that gas times 24. It wants it in decimeter cube, so I'll keep it in decimeter cube, 24 dm cube. 0.02 times 24 is 0.048 or something close to that. 24 times 0.02. 0.48 decimeter cube. And that's it. We did a 3-marker. What do you guys think? Molecular salam? Oh, I think Hassan. Oh, you're from Sir Bilal's class. Ah, okay. What's up, Saad? How you? What's up? How'd you find my channel? I guess I commented, that's why. ठीक है. There are a few students in my class also called Saad, that's why I'm confused. Molecular salam is, Hassan came earlier and said, Assalamu alaikum, and I just said, yeah, replied to him. Then he deleted his comment, like the little, oh well. Let's see if we can do this question. When lead nitrate is heated, 2 gases are given off and solid lead oxide remains. Equation for the reaction is as shown. Lead nitrate forms lead oxide, nitrogen dioxide, and oxygen. Calculate the MR of lead nitrate. Don't have to do anything aside from calculating the MR. What is lead on the periodic table? It's Pb. Pb, where can I find Pb? I can never find Pb. It's 207. Lead is, I don't want to use blue. Lead is 207. What else is there? Nitrogen. So I'll just figure out the MR for NO3 together, because I know nitrogen and oxygen, we just did it. 14 plus 3 times 16 in one go, 62. So that's going to be 207 plus 2 times 62, which is plus 207, 331. 6.62 grams of lead nitrate are heated until no further change in mass. 6.62, 331. 662, 331. Wow. Calculate the mass of lead oxide produced. So they want us to jump directly into the mass. So figure out the moles of lead nitrate. That's moles of PbNO3 twice are going to be 6.62 divided by 331. 6.62 divided by 331 is 1/50. I hate this calculator, my other one broke. Moles. The ratio between lead and oxygen is 2:1, right? So I don't have room to write it down, so I'll just write it over here. The ratio is, for every 2 of this, I'm producing 1. So I'll be producing half this amount, which is moles of oxygen are going to be 0.01. I hope that makes sense. I know the ratio part is the most difficult one, but I hope this makes sense to people. Let's get orange out. Mass, the mass of oxygen produced is just going to be moles times the MR, same equation rearranged, 0.01 times 32, which is just 0.32 grams. I'll confirm using a calculator. Yeah, 0.32 grams. Calculate the volume of oxygen produced at room temperature and pressure. So I don't need to do anything aside from picking a good color. Let's go with green. Volume is going to be the moles times, do they want it in decimeter cube? Yes, they do. So I'll use 24 dm cube. If they asked for it in centimeter cube, I'd use 24,000 centimeter cube. Okay. And this is 0.01. Why am I using 0.01? That's why. Times 24 decimeter cube. I don't have to calculate anything again. And this is just going to be 0.24, but I'll confirm. 0.1, it's 0.01 times 24 is just 0.24 decimeter cube. Purest, I'll put the units. Okay. The ratio is 1:1. Did I make a mistake? Yeah, you said class, you have your own YouTube channel. I do, yes. Why don't you? I can't remove the delay. This is how things work. It takes time. Sir, it's 1:1 for Romanberg. What part are you referring to? What's 1:1? The ratio of, this is 2:1. The ratio is over here to over here. Oh, it's 1:1. I understand. Okay, I made a mistake. Calculate the mass of lead oxide. Oh, you're right. I just thought they were talking about oxygen. So my next question is probably wrong as well. Yeah, great. So that's the moles of lead nitrate and the ratio. We're not talking about this guy yet. Actually, let's just leave it there because maybe we'll need it. The ratio is 2:2, so the ratio between these two is 1:1. I thought they were asking about mass of oxygen, not lead oxide. I made a mistake. And let's go back to orange. So the mass of PbO is going to be the moles times the MR. The moles are 0.02 because the ratio is the same between the two, right? 2:2. And the MR, for this I have to figure it out. Lead is 207 and 1 oxygen with it. So 207 plus 16 is 223 times 0.02. Thank you for correcting me. 4.46 grams. Okay. Now they're talking about the volume now, and I think this is fine because I used the moles. I just found out the moles with the ratios. This is fine because I didn't need anything from here. I just needed the moles from here, and I calculated that, and I think that working should also go here. I'll add that working. I'm focusing on PbNO3 twice to the ratio moles. The ratio is 2:1, and what do I have? 0.02 will give me 0.01. So the moles are the same, right? Like I didn't make a mistake while calculating the moles of oxygen, and I used that for this calculation, and it's fine. So I'm getting 0.24. Okay. Hi Asher, how are you? Let's try this question. Any questions so far? Sir, by the way, why don't you remove the delay? Yeah, okay, that's the thing. Okay. Roman, I owe you. ठीक है. Barium carbonate decomposes when heated. Barium carbonate. A student heated 10 grams of sample of barium carbonate until it's fully decomposed. Calculate the number of moles of barium carbonate the student used. How do we do this? Moles will be equal to the mass of barium carbonate divided by the MR of barium carbonate. The mass of barium carbonate is 10 grams and the MR, I'm pretty sure the carbonate ion has a MR of 60, I just remember it. Let's confirm. 16 times 3 plus 12. That is 60. Carbonate CO3 is 60. I'm just skipping a few steps. This entire portion is 60 because I see it so many times I remember it. Barium I don't know. So barium I look at the periodic table, it's 137. 137. ठीक है. How are your mocks going so far? Or grand tests? 10 divided by answer is 0.051. 0.051 mole. Calculate the volume of carbon dioxide gas produced at room temperature and pressure. Give your answer in decimeter cube. Okay, this is the moles I had of barium carbonate and the ratio between them is 1 to 1. So I don't need to do anything. These are also the moles of carbon dioxide produced. Moles of, oh, why am I saying moles? I already know it. Volume of CO2, actually, volume of CO2, have to use different colors. 0.051, I'm sure it's going to ask for in decimeter cube, times 24. And I'm getting 1.22 decimeter cube. How's it going? Asher, where did you find out about my videos? Like, I don't think we haven't met ever, right? The student added 2 grams of barium oxide produced to water. Calculate the mass of barium hydroxide that can be made from 2 grams of barium oxide. Okay. It's the same question. If you had 2 grams of this, if this was 2 grams, they're only asking for 1. Yeah. Okay. Figure this out. If you had 2 grams of this is what the question is. If you had 2 grams of this, how much would you produce? So barium oxide, I think they want you to do the shorter way, which I don't really discuss. So we'll do the longer way. Moles of barium oxide are equal to the 2 grams I have divided by barium is 137 plus 16, 153. 2 divided by 153. 0.0131 moles. The ratio is the same. So moles of barium hydroxide are also 0.01 because the ratio is 1 to 1. So now I gotta find the mass of BaOH. The mass of BaOH is going to be the MR of BaOH times its moles, right? Easy. And they're all the same question, right? So, you know, like, can't emphasize that enough. Moles times the MR. People actually just rectify the process and just get most of the moles questions right because it's so mechanical. It's the same thing over and over again. The MR for barium hydroxide is going to be 16 plus 1. I said 16 plus 1 times 2 plus 137. 171. multiply that by 0.0131, and we have 2.2 grams, 2.24 grams. Yes. Ah, okay. Who's your cousin? Who is your cousin? And what school do you go to? I think this is a difficult question. We'll skip this, and we won't have those. Let's try this out. Teach cousins. Man, you can't share anything. It's a very one-sided thing. Mohammed Jawad, okay. Alright. Yeah, alright, that's pretty cool. Not 3 people watching, no one wants to learn moles. I like how people who are getting like really good marks in moles showed up. Oh, well, like, it's optional. Yeah, I shouldn't. I have my teacher mode on. I shouldn't, not on YouTube. Like, I'm teaching, but I should be more, less worried about attendance. Anyway, ammonia reacts with chlorine. The chemical equation is shown. Calculate the volume. People say I say volume wrong. Volume of chlorine measured at room temperature and pressure needed to react completely with 0.68 grams of ammonia. I was too focused on volume, I didn't read the question. Calculate the volume of chlorine needed, measured at room temperature, needed to react completely with. Okay, this is what I know, this is what I want to find out. I want to find this out in volume. This is given to me in mass. So I convert this into moles first, then figure out the moles of this, but I don't want this, I want the volume, so I'll convert it into this. So step 1, oh well, that's the same step, 2, 3, that's the answer. Okay. Let's try that out. Actually, that's not a bad idea. I think most people get confused as to what we're doing. So let's write that down. So what's given to us is, or like, what are the facts? Mass of NH3 is given to us, which is 0.68 grams, and they're asking for volume of Cl2. That's what I have to find out. Okay. And so I'll use the mass of NH3 to find out the moles of NH3. Then I'll use ratios to find out the moles of chlorine, which will give me the volume of chlorine. That makes sense? I hope it does. Let's bring this here without, why can't I write in a straight line? Okay, let's erase this. What's the best color to use? I don't know. Okay. Moles of NH3 are going to be 0.68 divided by the MR, which is 17. 14 for, this is 14, 3 hydrogens are 3, so 17. And this equals to 0.68 divided by 17. 0.04 moles. Step 2 is ratio, and if I'm looking at it, Mass was given to me. I found this out. Now I'm over here right now. Ratio is between what's my known and my unknown. Ammonia and chlorine. Ammonia is 2. Chlorine is 3. If this is 0.4, how much is this is going to be? So I think it's going to be 0.06, but I'll calculate it anyway. Divide by 2 times 3. And yeah, I made a mistake. Wait, no, it's going to be 0.04 divided by 2 times 3, and this is 0.06 moles. These are moles. So I found out these two. Last but not the least, I have to find out the volume of chlorine. The volume of chlorine, which is going to be 0.06. And this time around they're asking in centimeter cube, which is I'm not too happy about because I ran out of space. But I could have written down 24 decimeter cube. I have issues. And this comes out to 1440 centimeter cube. Easy, easy, easy. Sample of gaseous element Y occupies this much room temperature. Can we, okay. Yeah, this is a nice question. I wish this was in your exam. Why didn't I find this earlier? I like these questions. They really challenge you. There's a mass of some sample of gas that occupies this much of space. The room temperature and pressure is this much, like at room temperature and pressure. Determine the number of moles. Okay, like you want to eventually find out the identity of the gas. That's pretty cool. You can just measure a volume of gas, and if you know the mass and the volume, you can figure out what gas it is. That's kind of cool. Okay, the moles is straightforward, but I'll change the colors I'm using. Let's use a brighter shade. Moles is volume over 24,000. Volume is 60, 24. And of course I use 24,000 because this is given to me in centimeter cube, right? So 60 divided by 24,000 is 0.0025. 0.0025 moles. Calculate the relative molecular mass. How do I do that? How do I do that? The only equation I know for the relative molecular mass is mass over MR, but you know, I need two of these things given to me. The mass was given to me. The question, how do I get the moles? How do I get the moles? How do I get the moles? MR equals to the mass over the moles, which is 0.095 divided by 0.0025, and I get 38. Argon? Is this argon? Is this argon? No, that's 40. 38. I don't have a gas that's 38. I don't have a gas that is 38. So what's half of 38? Divided by 2, 19, right? And I'm gonna guess it's fluorine. Why? Because if I look at the periodic table, I can't find the MR 38. That's a gas. There's no 38 anyway. So I'm thinking it could be a diatomic gas or triatomic gas or, you know, whatever. And I just, you know, divided it by 2 if it's diatomic. And fluorine. This part would have been a bit more trickier. I would have preferred if they gave us like a what do you call it? A noble gas, so it's easier. But yeah. What do you guys think of this question? What do you guys think of this question? Same thing? 0.025? Am I off? No, I'm getting a really nice answer. Isn't it 0025? Arham? Why don't you remove the delay? I was expecting slightly more people just, having a lot more fun in the comments. So I'd be more motivated to do this. What do you guys think of this question? Should this be in the test or no? Great. Okay. Nice. I'm glad you enjoy it. If you're enjoying this, then yeah. How many questions do we have? I think we're halfway through. Oh, it's continuing? Phosphorus. Wait, are they telling us if it's a sound? Do they tell us anything about it? No. Okay. The phosphorus was burned and formed 3.87 grams of an oxide of phosphorus. Calculate the empirical formula of this oxide of phosphorus. Oh, we don't. Yeah, we won't do this question. I think it's a little more difficult. This is hydroxide. Yeah, I think we can do this. Calcium chlorate. This nightmare is calcium chlorate 5 is made by reacting calcium hydroxide with chlorine gas. Okay, this is calcium hydroxide, chlorine gas. 8.88 grams of calcium hydroxide react with 7200 centimeter cube of chlorine gas are mixed together. So, okay, I'm just... How many moles of is 8.8 grams of calcium hydroxide? The moles are what's a good color to use? The moles are, tell me good colors to use. 8.88 divided by the MR of calcium hydroxide. Calcium is 40 plus 2 times 17, because a hydroxide is 17. I'm just doing it directly. 40 plus 2 times 17 is 74. 8.88 divided by 74 is 0.12 moles. 0.12 moles. How many moles of chlorine gas are there in 7200 centimeter cube? That's easy. Volume. The volume is equal to 7200 divided by 24,7200 divided by 24000. It's 0.3. What is the maximum number of moles of calcium chloride that can be made from 8. Okay. I think they're going towards a limiting factor question. This is a limiting factor question. Okay. If you have let's get a brighter color as well. If you have 0.12 moles of this and 0.3 moles of this, the ratio is 1 to 1. So if I have 1 molecule of this, I'll need 1 molecule of this. So technically, they should be. What part are you asking, Aram? Isn't it moles and not volume? What part? Are we talking about the same question? Question 12? A part, which part? I'll continue meanwhile you answer. So it's 1 to 1. So 0.12 moles of calcium hydroxide will require 0.12 moles of chlorine gas, right? So I'll have some chlorine left behind. So this is an excess where this is the limiting factor. And let's confirm that if we take chlorine into account, if I have 0.3 moles of chlorine, the ratio will be 1 to 1, right? So I'll also need 0.3 moles. Do I have that many? No, I do not. So again, this is an excess, this is the limiting factor. So you will just have 0.12 moles of calcium chlorate can be made. So the ratio between these two, oh, I am doing it wrong. I did it wrong. So you know they're reacting, only 0.15 of each will react, right? And they're asking how much of this will you produce. So if you're reacting 0.12 of calcium hydroxide, you can pick any one. So what's the ratio between them? The ratio is 6 to 1. Because if I'm looking at calcium hydroxide, it's for every 6 moles, I produce one of these. So the ratio between this and this is 6 to 1. So if I have 0.125 over here, how much of this will be? Well, 1/6 of it, which is going to be 0.02. So I'll just do the math over here one more time. If this is 0.12, this is going to be how much? That's just going to be 0.12 divided by 6 multiplied by 1, which comes out to be 0.02. And you'll produce 0.02 moles of calcium chlorate. Calcium chlorate. Part 2, I miswrote. Yeah. For creature fappet. ठीक है. What is the maximum mass of calcium chloride that can be made from this? So you figured out the moles. Now it's a simple process as figuring out the mass. So the mass is going to be the moles of calcium chlorate 5 times the MR of calcium chlorate 5. The moles are 0.02 and the mR, what is calcium chlorate? Let's figure that out. 16 times 3 plus 35.5 times 2 plus 40. I'm getting 207 as the MR. Times 0.02. 4.14 grams. I'm tired. This question was long. Has Ramsha left the building? Okay, we're not working on yields because we didn't talk about yields. Okay, let's go with last question of the day. Let's try this out. Last question of the... It is too quiet, right? Maybe next time we'll do it on Zoom. So people can talk more directly, and this also goes on YouTube, so people can also watch it later. Or I'll just record a Zoom. I don't like the Zoom recording, it just doesn't look as nice. I think this looks better. The, you know. You can't get that on Zoom. Why is she gonna haunt me? Don't put names here, by the way, unless people are comfortable with their names. If she's not here, she's not here. But why will she haunt me? I said it out loud, now it's undeletable. but I hate 21st century. It's gonna happen. It's gonna happen. It's gonna happen. It's gonna happen. Okay, let's start. Last question. Calculate the volume of chlorine gas. Door open. Calculate the volume of chlorine gas Cl2 at room temperature and pressure. What time is it? 2:40. 40 minutes and we're tired. I'm tired. Calculate the volume of chlorine gas Cl2 at room temperature and pressure that reacts completely with 400 grams of titanium oxide using the following steps. Calculate the relative formula of, they're just helping me through the entire question. So titanium is 48. I didn't know it was that light. Plus 2 times 16. That looks like 10. This is 80. Calculate the number of moles in 400 grams. Wow. 400 divided by 80, isn't that just 5? Determine the number of moles of Cl2 that reacted with. Calculate the volume of chlorine gas. Okay, determine the number of moles of Cl2. So the ratio between titanium oxide to chlorine are 1 to 2. Jesus. 1 to 2. If I have 5 moles over here, I'll have 10 moles of chlorine reacting. So the moles of chlorine are 10. So easy. I didn't even need my calculator for most of it. Calculate the volume of Cl2. Well, that's just going to be moles times 24 decimeter cube, which is 240. This was really easy. Huge contrast to the other questions we had. February, March 19, 0620. Question 5. ठीक है. I think that's it for the day. Do you guys have any requests or any questions? I'll also do another session with some MCQs maybe, and we'll do a lot of questions related to some questions. I think another hour session of some P2 questions, theory questions, covalent bonding, atomic structure, just as a revision versus like what to expect in the exam. ठीक है, your exam is going to be challenging because you'll be, I don't think anyone's going to finish the paper. Bro gang incoming. Now people are going to show up. Hey Asan, how are you? ठीक है, anything you guys want to let me know, you can, comment it, I guess. Zoom next time, do it on Zoom. I'll think about it. I actually don't want to use Zoom. Why Zoom? What's wrong with this? So you guys can talk to me directly. That is probably valuable. ठीक है. Let's end it here. I'll just wait a few seconds if someone wants to say anything. If you don't want to say anything, just say Allah Hafiz or show me the nail polish emoji. The grand test is going to be time consuming, not hard. The 4th, the exam. I'm talking to my students. They have a test this Thursday, I believe. Yeah. They'll be pushed for time. All right, guys, I'll end it here. Bye bye. Leave comments if you have any, questions or like any requests or focus on this thing. I'll do one, maybe tonight or tomorrow we'll do a session on uh, random theory questions, covalent bonding, atomic structure. We'll do that. All right. Bye bye, guys. Take care. Allah Hafiz.